In this video, we're going to look at a forces question where the forces are given in their I and j components. So, for example, we've got a force here, 9I minus 3j newtons. The first question is find the resultant. Well, the resultant is just the sum of the forces, and in this, when they're given an ij component, it's very simple. We just add the force up. So we have 9I minus 3j, that's my first one, and then plus 5I plus 8j, that's the second force, and then plus minus 7I plus 3j. That's the third force. Okay, now we sort of collect I and j components. So how many i's do we have? Well, we have 9i, and then we have plus 5i, then we have minus 7. That's the number of i's. And how many j's do we have? We have minus 3 plus 8 plus 3j. Okay, and this is pretty simple. 9 plus 5 minus 7 is 7i, and minus 3 plus 8 plus 3 is 8. So my resultant force is 7i plus 8j. Next part, find the magnitude. Well, a 7i plus 8j force, this is a triangle, isn't it? It's 7 in the I direction and 8 in the j direction. And the resultant is the sort of combined force, and the magnitude is the length of that. So we're just going to use Pythagoras to find that length. We need the square root of 7 squared plus 8 squared, which is square root of 113, which is 10.63 newtons to 2 decimal places, if we want to do it that way. Okay, so that's the magnitude of the force. Given that the particle has mass 5 kilograms, find the magnitude of the acceleration. Well, we've got the force, so let's just call F is 10.63 newtons. That's the magnitude of the force, and remember, F is equal to ma. So we're told that the mass of the particle is 5 kilograms, so 10.63 equals 5a. Well, that implies a equals 10.63 divided by 5 is 2.126 ms to the minus 2. That's the magnitude of the acceleration. So we haven't, in this case, we're just treating the acceleration we're not looking at the vector acceleration, we're just looking at the magnitude of it. Finally, find the angle between the resultant force and the vector I. Okay, well, this is, again, we just go back to the triangle that I drew earlier. We have this triangle which is 7, 8, and remember the I direction is this direction, so that the angle between the resultant force, which is the hypotenuse, and the I is this angle here that I've just labelled. So let's say that's theta. So using basic trigonometry, tan theta equals opposite over adjacent 8/7. So theta is the inverse tan of 8/7, which is 48.81 degrees to 2 decimal places.